Hi everybody, my name is Jason Tu, and today I'll be talking about computer science for all. Let's talk about potential real quick. Let's take these tables for example. These tables are made in a factory, and the factory had robots. Those robots ran on code. Phones, great example, projector, TV, everything. All of that includes code. Now, code also goes into different areas of study, like economics. There have been multiple different programming languages created specifically for stock trading platforms. There's also food. This is part of a movement in Japan called food hacking. So what a programmer did is he pretty much analyzed tons, millions of recipes, and he created links between each recipe that would say, hey, this is a good combination. For example, this is carrots, black olives, and some other stuff. Artificial intelligence is a really big application of CS. For example, at Drexel University, they're taking Legend of Zelda maps, and they're generating even more. So if you gave this AI about 8 or 9 different maps, you would be able to generate something like this. This is another Legend of Zelda map that is totally playable. And an application of this would be you could have infinite amounts of maps. Mario would never be able to find his princess. So if this potential doesn't awe you, perhaps President Obama can, or Dr. Oz, or even Snoop Dogg. And computer science isn't something foreign. It's for everyone. Just this last summer, I tutored a 4th grader in computer science. She learned how to play violin on the computer in less than 2 weeks. So it's something that's really approachable by everyone. Nope. And computer science isn't a foreign field. Let's take a look at these 2 definitions real quick. Art is the expression or application of human creative skill and imagination, while science is the study of the structure and behavior of the physical and natural world. Now, I get how physics is a science, I get how biology is a science, but I don't get how computer science is a science. I don't see code written on rocks, nor do I see apps in the air, although I wish I did. I see apps in my imagination. I see code in people's creative skills and imaginations. For example, there's a painter. Here's an analogy. A painter looks at a landscape and says, hey, this is pretty cool. And what they do is they convert it onto a canvas. A programmer, on the other hand, has an app idea and converts it into a program. Now, on a more personal note, this is me, 9th grade, at a hackathon at MIT Blueprint. A hackathon is a competition where you have generally 24 hours, this was 8, to code something. You go in with absolutely nothing and you come out with, hopefully, a fully functional app. I knew absolutely nothing. All I did was get refreshments for my teammates this year. And so when the hackathon ended and we went home, I felt absolutely useless. So I decided, hey, I'm going to learn computer science because it seems like something that's readily available and has a lot of potential. So I picked up Android Studio. Android Studio is something that you use to code Android apps. And I'll give you guys a quick live demo of how to do it. So right here is what you'll see when you create a new project. And if we switch over to this file, we get to see this, hopefully. Yeah. So this is a screen of the Android app, and currently it's blank because we have nothing in it. For example, we can see the Wi-Fi signal, etc. So there's that, and right now it's just drag and drop. It's really fundamentally simple. So if I drag that in, text view, right there, and then if I take a button and drag it right under, just anywhere, what I can do is I can even change it, what the button says right over here. So if I change that to, oh, click me, and button changes over here as well. So if I switch over to the code, we're just going to write a few lines of code. That's all it requires. So first I'm going to create an integer, which is just like in your regular number system, called clicks. Instead of using x or y, I'm going to use a variable name. And in here, I'm going to get the button, because the computer doesn't know where the button is. So I'm going to say, hey, let's find the button. And it should be button right there. And right now, I'm going to set an on-click listener. What the on-click listener says is, it tells the button, listen for a click. If you hear a click, run the code that's inside here. I'm going to apply the same logic to find the text view, which is like a text box. Text view right there. And I'm going to set the text to clicks. And after I set the text, and after the button hears a click, it's going to increment clicks by 1. Just like that. And if I run the app, it should show the application with a button. Now, this is Android programming, and there also is iOS programming, which is a lot simpler. In fact, that there aren't as many semicolons or as many foreign words. So if we click the button, it should update from 0 to however long I wish to press this button. Now, if we go back to the PowerPoint real quick, this is a basic application of Android programming. I just created an app in a minute tops. This application is seen everywhere. Snapchat, you press a button and it takes uses the camera to take a photo. Flappy Bird, you tap the screen and it bobs the bird up and down. Now, this is a screenshot of an app called Stoic Hub that I programmed for Conestoga High School. It used to be called Pinnacle app back when we had Pinnacle. But essentially what this does is it navigates the user from one place to another. Now, this may seem advanced, but how the computer thinks is actually quite simple. If we're at room 136, the computer has two options, to go either left or to go right. So the computer says, why don't I go both ways? It splits a person up into two, essentially, and sends one person left, sends one person right. And at every single intersection, it does the same. It splits the person up again. So when everybody reaches a dead end or the destination, it then says, hey, of the people who reach the destination, who has the least amount of steps? The person with the least amount of steps, hence, has the most efficient route. Now, there are other apps, such as OneShare, that I've been working on with a few friends. And this is started this all in 9th grade. And what OneShare does is, instead of having to share your Instagram info, your Snapchat, your Facebook with another person, all you need to do is you need to share a 4-digit number. Once you share that 4-digit number, your contact information is automatically transferred to the other person. And if you update your info, they get an updated copy of your info as well. Now, with this knowledge, I went back to Blueprint, junior year, and won 3rd place. So this shows that you don't need to be born with talent like music, nor do you need to start in 3rd grade like for math competitions. All you need to do is be able to go on Google and search up, how do I code? And the boundaries are limitless. From here, you could go on to create your own startup. You could get funding. You could get an app in the Play Store that has ads and get some pocket change for college. Now, furthermore, this is something that is available to everyone. It's free, not like other fields of study where you have to have an instrument or you have to have a textbook. Everybody has Google, and we have internet access throughout the entire day. Now, while I was wondering how to end this TED Talk, I decided to look up how to code. I got 1.6 billion results, which is good. Internet's a very large place. But I needed some sort of comparison, so I said to myself, cooking. Cooking is an essential life skill. So I Googled that, and I got 68.9 million results only. Now, this shows me that people value how to code more than how to cook. But furthermore, it reaffirms that coding has a lot of resources. So with that, I challenge you guys to go home and look up how to code. Thank you. Any questions? Yes?
How do you know which resources are like the best to use or where to even begin? Because
Yep.
you do have 1.6 billion results.
Yeah, generally, because Google is kind of smart nowadays, the first result works. If you want to get more specific, like if you want to create games, YouTube is a great way to start because they have video tutorials. And you can ask anybody who's in ComSci Club even. Richard, for example, or me. We're all here. Anything else? Wait. Yes?
Do you have some app ideas that you're working on that you can share?
Yeah, further app ideas. I'm working on 5 projects right now. One of them is Leash. We just won the Swarthmore Hackathon last weekend using it. So essentially what people did is they would connect phones together. And if somebody would leave the group, if somebody wandered off 10 feet, everybody in the group would get notified and say, hey, this person's lost. Here are their coordinates. Another cool idea I was working on is SymbiArt. Essentially what you would do is you would have two people. They could be across the globe. And you can collaboratively create art together, whether that be through composing tunes, writing stories, or drawing sketches. For example, drawing sketches would entail you have 5 seconds to draw something, and it's end of your turn, it's their turn, they have 5 seconds to draw something, and so on and so forth until both users agree that, hey, it's finished. That's it. Cool. Thank you, guys.